result-driven senior data engineer with 12 plus years of experience in designing, building, optimizing scalable data pipelines and architectures in cloud and on-prem environment. He's an expert in big data analysis, ETL development, real-time data processing using tools like Spark structure streaming and Airflow, with a solid grounding in data science methodologies such as exploratory data analysis, feature engineering, and supporting machine learning models. He has a strong background in data modeling, performing tuning, and implementing best practices for data governance, security, and quality. He is an adept in Azure and GCP ecosystem with hands-on experience in Python, SQL, and distributed system. An adept at partnering with the cross-functional teams to transform raw data into actionable insight, enabling advanced analytical and predictive modeling at scale. He's an architect solutions using MS Azure PaaS services such as Event Hubs, Elasticsearch, Data Lake, Azure Kubernetes Services, Azure Data Factory, Strong Accounts, etc. He has experience with building ETL pipelines using ELK stack. He worked on containerizing the applications using Docker and Kubernetes. He is a Microsoft certified Azure solution architect expert and AWS certified solutions architect associate. Now I invite Mr. Kasi Viswanadh to take over the session and start his presentation. Viswanadh sir, are you online?
Yes, sir. Can you hear me, sir?
Sir, can you share your screen?
Yeah, sure. I'm sharing, sir. Sir, let me know if you are able to see my screen.
Yes, sir. Your screen is visible and your audio is also audible, sir. You can take over the session and you can continue, sir. Thank you, sir.
Thank you, Praveen, sir. Good evening, everyone. Welcome to the session of Forensic and Accountability in Blockchain Era. First of all, I feel privileged and thank you for giving this opportunity to join in this AICTE ATAL Training and Learning Academy program and to share my knowledge on these particular topics. Okay, today we are going to discuss about the topics. This is the agenda in high level. So we are going to discuss what is blockchain technology, traceability in blockchain, what is meant by traceability and what is how to do traceability in blockchain, and what are the smart contracts, smart contract forensics, and what is meant by decentralized identity and the challenges associated with that. Hope you are all excited to know about these emerging technologies. Without wasting much time, we'll jump into the actual topics. So to understand what is blockchain technology, right? I think many of the people audience who are joined this call might already know what is blockchain. Any idea what is blockchain? So let's understand first what is the definition of the blockchain, and we'll see some of the examples of what is the purpose and why we use this blockchain and all. So there are many definitions for the blockchain. People uses many definitions. Some people call it as a advanced database mechanism. Some people call it as a digital database, or some people call it as a distributed ledger. Okay. So we can say here it has a digital database, an advanced database or a distributed ledger, which is used for sharing the information transparently in a peer-to-peer network. So this can be a simple definition of a blockchain. Okay. So what we are calling it is nothing but a ledger. Ledger, everybody know, right? Like generally we'll use in finance for various purposes, ledger to record something, right? So here also, blockchain is nothing but a distributed ledger which is used for sharing the information in a transparent way, okay, across the peers in the network, or you can say in a business network. So there are various purposes of the blockchains that we can see here. Let's see one example. So here a person has requested a transaction, and immediately when he requested the transaction has been broadcasted to a P2P network, which is nothing but a person-to-person network here, which consists of a set of computers which are called as nodes here. Then all the nodes will validate whether the transaction is valid or not. Means they'll validate whether the user status is correct or not and the transaction is valid or not. Using various algorithms, it will verify whether that particular transaction is valid or not. So, and this transaction can be any transaction, right? It can be a cryptocurrency transaction or a contracts, records, or any other information. And once this transaction has been verified by these nodes, then it will create a new block, and then this block will get added to the blockchain with the consent from the each node in the network or each participant in the network. That's how the entire concept of the blockchain works. We'll see some example. So before going to see why the blockchain is important, let me give a small example, right? So let's consider a scenario of sale of a property, right? So if I wanted to make a sale of a property in traditional scenario, there will be many challenges associated, right? There will be a buyer and there will be a seller, right? Say for example, Akash and Varun, there are two people who wanted to exchange their houses, or like they are participating in this uh, property sale transaction, right? So Akash is the seller, or say Varun is the buyer. In a traditional mechanism, so once the money exchange is happened between the Akash and Varun, then the property ownership will change from the seller to the buyer, right? So after that, what happens? Both the parties, both the seller and as well as the buyer, record the transaction on their end, but neither of them can be trusted, right? So a seller can say, I have not received the money, even though he has received the money, right? At the same time, a buyer can say, I have sent the money even without sending that money. So these type of the problems can exist in a normal traditional mechanism. But so how we can solve these issues? So in order to solve these issues, what we need to do, we need to have a trusted third party required. But as soon as a third person enters into this transaction, already the complexity of this transaction has been increased, right? And that third person can be sometimes trusted or not trusted, and it could be a single point of the failure. So all these problems can be solved with the help of the blockchain. So how it solves the problem, blockchain, how it solves the problem is, it will create a separate ledger for both buyer and supplier, and all the transactions should be approved by both the parties, and as soon as they approved, immediately it will update in the transaction. So no person can say this is not correct, kind of, right? So in such a way, blockchain helps in various different sectors. In order to perfectly understand the blockchain, let's see one video illustration. So Praveen sir, is it visible screen or everything is okay?
Yeah, Kasi visible.
Sir,
Okay,
If
sir.
there is any sound, you just verify whether it is going to play properly or not. Sound.
once play
Okay, sir.
once, sir, I will let you
Yeah,
know.
yeah, sure. I'm giving the audio, sir. It's fine, sir, for this. Okay. So now let's see the example. Say, for example, you are purchasing a product in the Amazon. So you entered into the Amazon website and you selected the product and you checked out the product, added the items into the cart, and then you have made the payment, right? So what will happen? after you selected the product and added the items to the cart, and when you click for the payment, internally what happens? The user contacts Amazon, means sends the payment details to Amazon. Amazon internally will contact this MasterCard, Visa kind of the services, which internally contact actual your bank to verify whether you have a required balance or not. And once that confirmation has been made, then only what will happen? That Amazon will ship that product to you, and also you will receive a receipt from the bank that payment has been debited and that it has been paid for the Amazon. This is how it happens, right? All these transactions is maintained in this centralized ledger. So distributed ledger. So here we are calling, like we can consider this as an ledger, right? So it is a decentralized ledger. What is decentralized? We'll understand. We have many examples going forward. Difference between centralized and decentralized we'll got to know. Now, how this information is will get stored into this additional earlier days, right? So all this information is stored in the form of the table. But now, in this case of the blockchain, all this information, how it will be saved, you can see, right? It will be stored in the form of a block. So each block contains the information about these details. Who is the buyer? Who is the seller? What is the product that he is going to purchase? And then it has calculated a hash for all these values, right? So each block contains these values. Not only that, right? It has also associated, if you see below, there is something called previous hash. It means, for example, third block is associated with the second block hash. Second block is associated with the first block hash. So even though the content is changed, then the hash will not match. So in this way, integrity and authenticity of the transactions are maintained in the blockchain network. So in the peer-to-peer network, all these, for example, if a new block wants to get added, then there should be a consent required from each and every participant in the network. If a majority of the participant consents is required in order to get a new transaction block should be added into the network. So I hope now you got some high level understanding of what is a blockchain, right? How a block can be created, what a block can contains, what kind of the data that block can contains, and how it maintains the integrity and authenticity by using the cryptographic techniques like the hash algorithms and all, right? So that is one high level understanding of the blockchain. So you can see based on this, you can understand what are the various features that blockchain can help, right? Immutability, transparency, efficiency, traceability, and security. Let's see one by one. Immutability. Immutable means what? Which is not a mutable. Means which cannot be changed, which cannot be altered or modified or deleted, right? So, sorry. Okay. In traditional databases, right? For example, if you made a transaction, what will happen? If you made a transaction, means if the transaction has been recorded in a database, we have an opportunity that means whoever it is, database admin or someone can hack the database to modify the transaction, right? So basically a transaction can be altered, whether it can be updated or it can be deleted in the traditional databases. Whereas in this case of the decentralized distributed ledger, all these records are immutable. It means in blockchain, if a record has been inserted, then there is no way that it can be changed. So you can ask a question now, what if while recording the transaction itself, there could be an error? So what will happen in that case, sir? Yeah, even though there is an error in that transaction, we cannot modify. What we need to do is we need to create a new transaction to rectify that mistake. And both the transactions should be visible in that network. So that is how the records will be maintained in the blockchain. And as you see, transparency, right? So each and every participant in the network can see what is happening in the blockchain network. And efficiency. So as you see how fast it is, and many organizations started using this blockchain for various purposes. And traceability, right? At every point, the participants can be able to track and trace where exactly it is currently the status. right? The security, as I said now, just now, it includes internally the cryptographic principles like public key cryptography, which includes a combination of the public key and a private key. So if a particular person has sent the transaction, if you are able to decrypt the transaction using his public key, means you are able to clearly understand that the transaction has been originally done by the person whose public key it is, whose private key it is, right? So these are the various advantages that you will get when using the blockchain. So it is currently being used in the various industries: supply chain, government industry, energy industry, food industry, retail industry, healthcare industry, and education industry. There are various industries the blockchain is currently getting used. So how it is getting used in block supply chain, whenever means they are you people are you organizations are using the supply chain in the blockchain technology in the supply chain for tracking of the various goods, and as well as in the government. In case of the government, government is using this blockchain technology for storing this personal identity information, criminal backgrounds, and e-citizenship records for all this purpose. So energy, what is this energy? Something different. It is not a sector or a department, right? What is this? So let me give an example. Energy here, it is nothing but a solar energy, or like you can take an example, right? So you consider there is a gated community. There are lots of people who are living in that community, and one of the home buyer has a solar panel, right? And using the solar panel, he has got that energy. Some of the energy he has used, and but he is left over with some of the energy, and he wanted to sell that energy to some other people in the same community. So he can use this blockchain technology to create some trading platform in order to sell his energy, solar energy. All the people, so on, everything will be automated using the smart meters. It will measure how much amount of the solar energy has been consumed by the other people in that communities. Based on that, automatically the blockchain will record the transactions. So it helps in such a way, like in food industry also, in order to easily identify if there is any contaminated food, or complete end-to-end traceability from the product origin, batching, processing, expiration, storage temperatures, and shipping. Start from the origin till shipping, end to end. If you wanted to track, you can use the blockchain technology. Similarly, in the peer-to-peer network, retail particularly, whenever a shipment has been made from one place to another place, end to end, you can track it using that retail. Similarly, in the healthcare, in order to update the medical records of the people, patient records and all are maintaining currently in the healthcare by using this blockchain technology. Coming to education, in educational institutions are also using the blockchain technology to store the students' assessments, degrees, and transcripts. For storing for all these purposes, education institutions are also using the blockchain technology. Okay, so these are the various sectors currently where the blockchain is getting used. And these are some features we have already discussed, but we can just go through once again. Cannot be corrupted. As I said just now, the transactions which are once made cannot be altered, it cannot be modified, or it cannot be deleted also in a way that the records will not get corrupted. A decentralized technology. So what is the difference? Earlier we are using a traditional database mechanism will be a centralized. If there is something happens, that complete database will go down, or tables will be lost, data will be lost, everything. But here the decentralized technology. In the previous example also we have seen, right? For example, if a new block is getting created, so what will happen? That new block will be distributed to the all the people in that network. If a transaction has been made, if there are some 1,000 nodes in that network, if there are 1,000 participants in that network, everybody will have a copy of the network. If one person modifies, then it will not get modified in the other person's copy, ledger copy. So that is what the decentralized technology means. Enhanced security, as we see, right, whenever it is transmitting the information in the form of the blocks, information is getting encrypted using these cryptographic principles, and also integrity is maintaining by using that hash. Okay, and the distributed ledgers, as we have seen just now, what is a distributed ledger? That ledgers are maintained as soon as the transaction is happened, then it will get the consent from all the people in the network, and immediately it will get updated in the all the people's copy of the ledgers consents. So as I said just now, for example, if the transaction to be recorded, then it should get approval from all the people in the network, majority of the people in the network, then only the transaction or the record get be accepted, and then it will be considered. Faster settlements, as you see, because of all these advantages, transactions in various sectors, it is going fast, and for faster settlements people are using this blockchain technology. Now let's see what are the basic building blocks, I can say, right? What are the basic building blocks or the underlying internal structure? What are the components present in the blockchain architecture, right? So based on the name itself, you can understand it is a blockchain. What it contains, a group of blocks or a list of blocks will be there, and they are linked together. Then we are calling that as a chain, which is nothing but a blockchain, right? So here, a simple terminology, what we are seeing here is a node. A node means a computer in the blockchain framework. We are calling it as a node. Okay. A series of nodes, we are not calling as a chain. Chain is nothing but a series of blocks. Please understand the difference. Blockchain is not a series of nodes, it is series of blocks. Okay. So node is a computer in the blockchain framework, and there is a series of the blocks in the particular order, which is called as the chain. And then a simple independent tiny building unit of a blockchain is called as the transaction. Okay, and a set of particular nodes. Here we have seen a node, right? A node means nothing but a computer. So here we are calling that set of particular nodes which authenticate the new blocks in order to get them added into the blockchain network. Those are called as the miners. Okay, a single block which has some structure, what type of information that it will store, we have seen, right? In the case of the buyer supplier transaction, payment transaction, what are the information it has present? A buyer name, seller name, what is the amount of the transaction that has been exchanged. All this information is getting stored in the block, right? So that information which is present in the form of a block. What is consent? It is nothing but a consent from a participant, right? So blockchain has designed in such a way that every participant in that blockchain network has its own protocols. So majority of the users, whenever they approve, then only the new block will get added to the network, like, right? So we should definitely need a consent from each and every participant. So these are the basic building blocks from a blockchain. A node, which is nothing but a single computer, a chain of blocks, which is the chain, and simple independent unit of a blockchain system, which is a transaction, and set of computers who will authenticate to get a new block to be added into the system, which is called as the blockchain. A simple block which contains the what you call what is the information about the transaction, that will be called as a block. And then this can be if the new block needs to get added into the network, whatever the consent that we will take from the majority of the participant is called as the consensus, right? So if how the blockchain will work, right? So this is the same example that previously we have seen. We are now just seeing high level again. User has requested the transaction, you can see. Then immediately once a user requested the transaction, a block representing the transaction got created here. Then this block is getting broadcasted to all the nodes in the network. Then this transaction, all the nodes which are available in that network should validate this block. Then the block it get added to that network. Then the transaction gets complete. So this is a high level simple workflow, how it happens in the blockchain network. So if you see the types of the blockchain network, there are total of 4 types of the blockchain networks we have. Public blockchain, private blockchain, federated blockchain, and hybrid blockchain. So if you wanted to clearly understand what are the types of the blockchain, in order to remember the various definitions and all, the best way is if you see this picture, you can clearly imagine on the left side of the picture there are some simple images, easy to understand. If you clearly understand that picture, you can easily remember what is the public blockchain or what is private blockchain and all, right? So total we have 4 types of the blockchain here: public blockchain, private blockchain, federated blockchain, and hybrid blockchain. So if you see a public blockchain, anyone can join this network. It will be an open ledger, you say, right? So it is not, it is permissionless. Anybody can join this network. That is what called as the public chain network. And these transactions definitely can be anonymous, but it will be fully decentralized, and anyone is allowed to participate and give their consent, can join this public chain network, right? But in the case of the private chain network, it will be maintained by a single organization. So that organization will decide who are the participants who can access this ledger and what type of access they can have. All this will be controlled by a single organization. That is called as the private blockchain. Okay, next one is the federated blockchain. So federated blockchain, if you see, it is also called as the consortium blockchain also. People call it as a consortium blockchain. It is similar to the private blockchain, whereas the private blockchain is maintained by the one single organization. In the case of the federated blockchain, it will be maintained by a group of organizations, right? For example, there are some 4 or 5 organizations who has the same goals, same business goals. So those kind of the organizations will come together and they'll maintain a federated blockchain or something called as the consortium blockchain. And next comes to this hybrid blockchain. Then this hybrid blockchain is nothing but, as you know, the term hybrid tells that it is a combination of both public and the private blockchain network. So a certain data which is present in the organization can be accessed by the everyone, but certain other data can be governed by that organization who can access that and what type of access they can have. So like this, there are 4 types of the blockchains we have in the concept of the blockchains, right? Public, private, federated, and the hybrid blockchain. So when it comes to the blockchain protocols, so there are various types of the blockchain protocols you can see here. I wanted to just say one word here. Here it is not nothing. Protocol means it's not exactly a protocol here. In case of the blockchain protocol, it's nothing but different types of the organizations, or you can say different types of the platforms which are available to build the blockchain applications based on the specific industry or the application needs. So it is nothing but a platform. Here the protocols are nothing but a different types of the platforms that are available to develop the various types of the blockchain application based on a specific need of that industry or a business, like, right? So out of all these, the first foremost one is the hyperledger. This hyperledger is one of the foundational blockchain platform. It is again open source. People can use this open source blockchain network. It is again, each of this platform will be helpful to build the blockchain applications of any of the type which we have discussed in the previous slide. So these ones can be used. So it can be used either to build the public blockchain, or it can be used either to build the private blockchain, or it can be used to build the what you call consortium blockchain and all, right? So particularly you can see here the Hyperledger, which is the foundational platform. It will help to build the uh, private blockchain kind of applications, and it provides some general purpose frameworks which offer some unique features like identity management, access control features. If you wanted to build a blockchain application with these kind of the features, then we'll go with the Hyperledger Foundation blockchain protocol or a platform. And then similarly we have Ethereum, Corda, Quorum, and multi-chain. Ethereum is generally used to build the public chain applications, and whereas the Corda again used to build the private chain applications, and Quorum is again it is actually derived from the Ethereum only. The difference will be Ethereum is used to build the public chain applications, and Quorum will be used to build the private chain application. And Coda can be used to build consortium applications. And multi-chain is again different chain of the means different platform which is used to build the blockchain applications, where it has the ability to speak with a private blockchain application can speak with the public chain application kind of, right? So that's where if there is a need kind of, then we'll use this platform in order to build that blockchain applications. So we can see the history of the blockchain. So you can see in this particular slide that it has been started in 91 and various important milestones has been given. But ideally, if you see the blockchain the roots for the blockchain are started in the 1970 itself. The person Ralph Merkel. I think majority of the people might be computer science. So did you use hash tree, Merkel tree, hash tree, and all, right? So in the 1970s itself, a computer scientist called Merkel has patented about the hash trees. What is a hash tree? It is nothing but a computer science data structure which can be used to store the data for linked list kind of item, right? It will, if you see in from the computer perspective, it will exactly, I mean, it will be little similar to this concept of linked list, right? So here also we have the list of blocks which are tied together, which is we are calling it as a blockchain, where you can say here one particular the hash of the previous block is maintained in the next. Similarly, in the linked list also we'll maintain that head and I mean the tail information of the previous one, double linked list and single linked list. I think you might have the concept. So that particular concept of the blockchain, the roots for the blockchain were already happened in 1970 when this Ralph Merkel has patented about the hash trees. Then in 1991, you can see Stuart Haber and Scott worked on the first blockchain transaction. Then the origin started in 2019. The first Bitcoin white paper has been released. In 2010, the first Bitcoin purchase of has been taken place, you can say. And then between 2011, 12, 13, Bitcoin transactions are happening. And a significant milestone in 2013, we are seeing there is a Bitcoin marketplace surpasses $1 billion transaction. And in 2014, Ethereum block has been introduced. And then 2015, smart contracts. We'll see next in the future slides what is a smart contract and all. What is a Genesis block? Genesis block, I think we can say. Let me take a pause here, and I would like to ask a question. So I was giving some in the at the beginning also I given shown some small animation, right? So how blockchain works. So a set of blocks will be there, and the transaction will be divided into each block, and then these blocks are tied together based on the hash and all, right? So for example, a third block has been contains the previous hash of the second block, and the second block contains the previous hash of the first block and all, right? Anybody got the doubt what will the first block contains then? So first block has its own data information, and it will contains the hash of that particular data also. But what about the previous hash of the first block? Does anybody got the doubt what it will contain the previous hash? Any responses I can expect from the chart? Let me see. Let's make it little interactive. Am I audible?
Yes, sir.
Okay. Is the question clear? One simple question. So in the concept of the blockchain, in the initial demonstration, I have shown, so there are multiple blocks in the blockchain. In order to maintain the integrity and authenticity of the blocks, the data which is present in each block will get hashed. Not only that particular data hash will be there, in each block there will be two hashes. One will be the hash of the particular block, and the other will be the hash of the previous block. If someone in between changes the data, what will happen? This hash value will not change, right? So we have seen a block contains the hash of the previous hash of the second block, and second block can contain the previous hash of the first block. What about the first block? In case of the first block, what will be the previous hash of the first block? Yes, engineers are already, Indrapreet Kaur has been said it is Genesis block. It does not contain anything, right? It is the very first block. So that's why it is called as the Genesis block. Okay. Then this is the complete, I think, history or origin of the blockchain technology that we have seen here. The advantages, again, the same, whatever we have seen pretty much in the features are now available as the advantages of the blockchain technologies. You can see here, the transactions are the immutable, which is nothing but once the transaction has been recorded, it cannot be altered or it cannot be modified. Anonymity and the privacy. User's identity will definitely kept remain anonymous due to the public using the public key cryptographic techniques, and there will be no intermediary third parties are required here. The digital freedom using the decentralized approach, and security has been enhanced using the cryptographic and encryption techniques and the lower transaction fees. These are some high level advantages of the blockchain technology here we can see. So now let's see a small differences between what is the difference between a Bitcoin and a blockchain, right? So many people, I think, they use these like a synonyms kind of Bitcoin and blockchain. They use it together, but there is a difference between a Bitcoin and a blockchain. From the beginning, what we are discussing, a blockchain is nothing but a distributed ledger for storing records of the transactions, right? But whereas a Bitcoin is an initial cryptocurrency. It is not a distributed ledger. It is nothing but an initial cryptocurrency. Similarly, when it comes to the objective, the main purpose of the blockchain is it provides the environment in the peer-to-peer network transactions. It cannot be just only transaction. It can be various things. Stocks, trading, everything can be performed using the blockchain. But whereas the case of the Bitcoin, it is mainly only for performing the transactions. But the only difference is why, sir, why to go for the Bitcoin in order to perform the transaction? Already we have various types of the applications and the processing institutions in government and third parties also, right? Why Bitcoin, right? So this is something, the transactions that can be performed without the government restrictions. That's where the Bitcoin, the concept of the Bitcoin came into the picture. Okay, the scope, the blockchain adaptability changed from more from support, post support to top companies and it limited to the role of currency only, as you see. As I said just now, trading, it is only Bitcoin can be perform only the currency trading, whereas the blockchain, it can involve the various things like stocks, contracts, and property rights, everything. And coming to the strategy, reducing the cost of the intermediate type of the transactions is the main motto of the Bitcoin. Effective responsiveness and traceability and tracking is the major motto of the blockchain. So that is where it differs. Bitcoin can be said, it can be one of the application from which came up from the blockchain, but it is not, both are not same. One is a distributed ledger and one is for mainly for performing the financial transactions without any government restrictions. Basically, it is a cryptocurrency, right? So coming to, if you see the similar differences between a blockchain and a traditional database, if you traditional database, when I say a traditional database, think about a very traditional database. Do not compare with a distributed database or a cloud database. So that's what I can say here when you compare these differences. So as we see data storage perspective, where the data will be stored in the blockchain in a distributed ledger. Whereas in the case of the traditional database, it will be a centralized server where we can see security here. It is getting implemented using the cryptographic techniques in case of the blockchain, and in case of the traditional, it can be traditional database, it can be vulnerable to the hacking breaches and all. Whereas it comes to the data integrity, it is immutable. That is what from beginning we are discussing. Whenever in case of the blockchain, this is the fundamental principle that we need to remember. Blockchain means some 3 to 4 words we need to clearly remember. It is decentralized. It is immutable, it is distributed, it is traceable, like kind of these things, right? So immutable, if a transaction has been recorded, it is cannot be changed. That is in blockchain. But in case of the traditional databases, you can perform, right? You have insert commands, update commands, delete commands. You can modify the data in the case of the traditional databases. Similarly, the data access control. So in case of the traditional databases, it is a centralized access control, whereas in the case of the blockchain, it is a distributed control. As we see, right, if a new block need to get added to into a blockchain network, we need the consent from each and every participant in the network if that block needs to get added. If any record transaction should be considered as a valid, there should be consent required from each and every participant or majority of the participants from, we need that consent from the network, right? So from in terms of the trust, limited trust and high trust in case of the blockchain, and then consensus mechanism, that's what we discussed. Scalability. Traditional databases definitely does not have any scalable. Again, scalability challenges are present with blockchain also. And then distributed, in case of the maintenance and control, it is distributed, but it is less centralized. Whereas in the case of the traditional database, you can see centralized and that maintenance and control has been managed. Now you can compare with the cloud computing. Previously, we have seen a traditional database, but when you compare with the cloud computing, what are the major differences you can see? Both are, so first one, data storage can be centralized and decentralized, but distributed will be applicable on both sides. So here is it is a distributed ledger. In the case of the cloud computing also, data can be distributed based on the cloud service provider. I think majority of the people might be using, right? What are the various types of the cloud providers we have? Major cloud providers. We have Azure, AWS, and the GCP cloud providers, right? So we can compare with any of the cloud here when we are comparing with the blockchain technology. The immutability that we have seen in case of the blockchain, it will be immutable, but in the case of the cloud, it is depends upon the application and proper authorization which you have given for that particular application. Security here it is implemented using the cryptographic security, whereas in the blockchain cloud computing a third party reliance. And then scalability, cloud is meant for scalability, right? So there is no problem for the scalability in case of the cloud, but this is a problem in the blockchain network. Coming to the cost, as you know, in cloud means first term what it comes to our mind, pay as you go, right? Whatever the services that you use in the cloud, for that only you will pay. That is what pay as you go, but potentially higher cost when you're implementing with the blockchain technology. That is the major differences that you can see. So now let's see the concept of traceability. So basically it is used for blockchain traceability refers to the ability of the track the movement of the assets or data across the blockchain network, right? What it can be assets or it can be data. Whenever it is moving from one source to another destination, the ability to track that movement is called as here blockchain traceability. For example, if you take in the case of the supply chain management here, business can track the journey of the goods from the source till end consumer. So why this is needed? Whenever you have this kind of the traceability, it enhances the transparency, it enhances the accountability, efficiency, and throughout the supply chain by reducing the risk of fraud and product recalls and all, right? We can see with an example, we can see. So for example, in the case of the supply chain using the blockchain technology, supplier initially provides the RFID code with the information about the product. Then the producer, he needs to ensure to meet that whatever the specifications that are given by the supplier has been met or not. And then he then generates that QR code for the traceability. Then the stock list, who is in order to get these products from the what you call here trusted third party service. We are from the warehouse distribution. Similarly, from the TPL service or to warehouse, how it is going to the retailer, from the retailer to store, and from finally from store to the customer. Everywhere, whenever the transaction is means whenever the particular event is happening, all that events are getting recorded in the blockchain network. So whoever in this particular network, if they scan that QR code, they can be easily identified about anything in this network. Like I can give you an example. I think Amazon has filed a patent based for this distributed ledger technology, which is using the blockchain to make sure that whatever the products that are purchased on their Amazon platform, to verify those are authentic. For that, Amazon has already filed a patent. It has built that distributed ledger technology using the blockchain. Using that, any who are the consumers who are purchasing the product, they can easily verify whether that products are authentic or not by using that scan code or QR code option which they are providing. They can get complete information about where that product is getting manufactured, through which all channels it has passed, what exactly happened at each event, and all this information they can be captured. So just now we have seen with this traceability, these are the various advantages that we have. Enhanced traceability is enhanced. Tracking and traceability, this will be improved food safety, increased transparency, and reducing the frauds can be reduced by following this traceability. Overall supply chain efficiency also will get increased with this, right? Let's see in some of the fields how this traceability is helping, right? Just now we have seen again supply chain. No need to give a separate example for this supply chain. In case of the agriculture, if you see, using this blockchain technology, if you maintain this traceability, consumers can be confident about the safety of the food that they eat, and by tracking its journey from farm to the table, they can get to know complete information, right? So then they'll be confident about the food they are getting it. So we are going to a hotel, for example. Say you ordered some biryani or you ordered something. When you go to hotel, do you know from where that source of origin, where that food get generated from farm to complete till when it comes to your table, what are all the various stages it has been undergone? This everything we can make it trackable by using the blockchain technology. Fashion, do you know whatever the products that you are purchasing from the various apps or from various online platforms, or either by in the shop also physically when you are purchasing, do you know exactly which materials has been used in the in this clothing, or what is the risk of counterfeit material, means the duplicate imitating, like not actual material has been used, and what are some unethical practices has been encountered? All this can be traced using the blockchain technology. Improved quality of the control, track the food products from origin to ensure that quality of the standards is maintained or not, you can see. Manufacturing also, different types of the raw material components in the manufacturing, you can completely basically allow the participants who are participant in that network, allow them to record the event, so that at the end you can completely trace and track that end-to-end shipment, or end-to-end anything in the particular different type of the sector, right? Based on the sector, you can track that completely. So coffee bean, okay, I think everyone loves coffee, right? It's the evening. I think many of you might have already taken the coffee. Yeah. So let's see one example case study here, how this traceability happens in case of the traditional supply chain consumers. Do you know when you are, by the way, what is your favorite coffee place when you plan to have a coffee? What is your favorite place? Is it a cafe or Starbucks? It could be, right? So we don't know, right? So we are taking the coffee, we are going to this particular Starbucks or cafe, and we are ordering the coffee, and coffee is coming to our desk. Do you know where this entire thing, where coffee beans are getting originated and all? No, right? So that journey we can see a simple journey here. In case of the traditional supply chains, consumer don't know what is the true origin of the coffee, and the farmers who has made these beans and prepared all this was paid fairly or not. We don't know all these details, right? It is maintained everything in some paper or some centralized digital logs. But if you maintain the blockchain, this everything can be tracked. You can see here, right? Register the item with a QR code. Then once it is went to the producer, production of the finished processing, you can see. Then once it is shipped to the distributor, where the delivery happens, and then once it is shipped to the retailer, and finally when it gets to the customer, everywhere every person will record this event, then so that all the participants in the network as well as the end customer can track this event, and they can easily identify the source from where it comes from and all, using this blockchain technology, right? So who are all the participants involved in this role in this network? One is the farmer, who initiate this chain by creating the first block of the data. Then the processor or the mill, who will add that farmer's data and process the details, and the shipper or the logistic, who will verify the product upon receipt and then record the transport events. Then the roaster or the manufacturer, who who verifies the imported shipment and the records the quality checks. Then the consumer, who is the final who views the final immutable record via the Q code, right? So these are all the participants. So who performs what action, we can see here, right? At the origin, what will happen? Farmer, what type of the event, when he register the event, what that event contains? It contains geographical locations of the farm where this bean has been prepared, proof of origin. And in the processing, mills will create an event. In that event, what type of information will shared? A processor ID, date of processing, a quality, a moisture content, all this information will get stored in that second event, which will ensure the quality control. Then in the third one, once the farmer register the harvest and once the processing is done, then it will be shipped to container, right? So that time logistics team who will record the event will create one event that event contain the information about container ID, transfer of the ownership, and all these details, right? Then the roaster, it will not be directly consumed, right? These beans should also be roasted. That roaster, when whoever is performing that, who will roaster ID, verification of the hash and all. Then finally, when it comes to the retail, all these blocks will be linked together and the complete blockchain events history will be ready for the consumer to see, track everything from origin, right? So advantages, don't want to spend again much time. These are the same advantages for at each and every application: immutability, transparency, speedy recalls. This you can focus here, right? While doing this process, if he found that some of the products means the beans are contaminated, then they can send back to the farm. They can easily identify from where it came, and then they can send it back that bag. So these are things we can say. Proof of authenticity. Retailers can guarantee the coffee, whether it is a genuinely organic or it is someone has altered this. It cannot be possible now, right? Because every transaction is now encrypted with the cryptographic techniques, preventing alteration. No one can degrade this in between. So farmer has prepared these beans and then it has been shipped to this one, and then it has been also sent to the logistics. In between, if someone tries to modify this low quality grades beans with the high quality grade beans with the low quality beans, this adulteration, these type of issues also will not be possible when you maintain everything transparent. Whenever everybody is tracking, these type of issues also will not be happen, right? Then the smart contracts. So what is a smart contract? Do you know contract? We know, right? Many times whenever we are performing we use it to hear business contracts. So smart contracts is also like a business contract, but here the simple definition will be, it's nothing but a program which executes when a specific condition is met. I think many of you are a programmers, right? Computer science programmer. What is the first step we'll do? I mean, whenever we are performing some conditional statements, what is the first thing we'll do? If and then. If a condition is met, then we perform certain action. That is nothing but a smart contract in concept of the blockchain. No need to mug up big definitions here. Before going to smart contract, I'd like to show the coffee bean journey once. Let's take a simple understanding of how this happened.
Made in a coffee maker.
Praveen, sir?
Yes, sir.
Sir, Indranil, sir? Sir, I'm just playing one coffee bean journey of smart contracts. Let me know whether the audio is audible or not.
Audible, sir. It is audible.
Okay, sir. Great. Thank you.
In under 2 minutes, think again. Hello there. I am a proud Arabica coffee bean. My journey has been long, and I have passed through many hands. Farmers, traders, shippers, insurers. The coffee supply chain has too many stakeholders. Have you ever wondered about my lineage? Did you know it has always been near impossible to track where or how your coffee was made? Until recently, when blockchain technology took over and brought accountability into the supply chain. Today, you can trace your coffee's journey from Brazil, India, or Indonesia from the very beginning. Are you enjoying my story? Let's move on to the next phase and look at the planting process. Miguel, my farmer, although a tad rough, was a great guy. He planted me in the best possible soil, protected me from harsh sunlight, and nourished me with water. He waited patiently until I was strong enough to brave the outside world before replanting me. Replanting took some time, and getting used to my snoring neighbor took even longer. Let's move on to the next phase of my life. Here's where I met Mr. Inspector for the first time. Pulling and twisting my arms and legs, he poked and prodded every bit of me. And recorded all my details, including my type, fertilizers used, farm, and family I came from.
Please understand here, this is what I was explaining previously. Whenever these things are happening, at every event, what type of information is getting captured in the event, right? At every stage, all this will get recorded and maintained in the centralized distributed ledger for the tracking purpose. Let's see.
from and stamp my tamper-proof origin certificate digitally. Then began my happy hours at the spa, or what Miguel calls harvesting and processing. I was plucked, hulled, polished, graded, sorted. Oh, bliss. All these while registration details, crop information such as variety, temperature, and humidity were being recorded. Finally, after getting stamped with a quality certificate, I was sent off to the next phase of my life, transportation. Want to join me in my next phase? Let me warn you, it's a rocky road ahead. The journey began with insurance. I was insured well. In case something happened to me, at least Miguel wouldn't lose his livelihood. Shipping was hard though. I had to say goodbye to many of my brothers before hopping into the Cisalbag. After a long journey, I reached the party central, the warehouse. I met so many other coffee beans from across the world and just chilled for a while. While I was partying, blockchain ensured that shippers delivered me to the right address. Miguel got paid in real time, and the importer got his delivery on time. This brings us to the last phase in my journey. You are now very close to your hot, steaming Coupa. I took a nice long sauna bath at the perfect temperature to retain my aroma, while the roaster recorded my details. Then, when I winked at you from the supermarket shelf, we both knew it was love at first sight. So, that's my life in a nutshell. It's all because of blockchain that you are sure of the authenticity of my origins. It has brought transparency into this dynamic demand chain. Blockchain ensures that nothing gets in the way of brewing your perfect shot of espresso. Take our trivia test, and when you are done, use the app next to the coffee maker.
See, that's how, right? So we have seen how many phases it has went through, and in all the phases, how this integrity has maintained and all. So that's one example of the life cycle or the means the coffee bean from farm to table, right? So that's how we can see a real life implementation, how this blockchain is implemented in the various technologies. Okay. Now let's see what is smart contract. We just discussed the definition of the smart contract. It's nothing but a program which executes based on a specific condition when specific condition is met, right? So it is a simple example. It's nothing but an if then. Okay, if the condition is met, then do this. That is nothing but called as a smart contract. Okay, so what are the how does the smart contract works, right? So these are the things that will present in the smart contract. Contract terms, predefined contract, and contract is written into the blockchain, and event get triggers to the execution, and then assets are released to the parties, and transaction is settled, and the details are stored in the blockchain. So one simple example I can give blockchain for this smart contracts is, for example, a goods has been shipped from one place to another place, then there should be a smart contract auto payment. As soon as the goods are delivered, then you make an auto payment to that shipping company or something like. So if the condition is met, then perform this action. So these kind of things will happen in the smart contracts. So before going to the smart contracts 4 and 6, let's see what is smart contract example. Another example, escrow. You see, right? Online purchase. You don't know, right? No, we are currently purchasing many things from the online. We don't know who is the actual seller, but for buyer it is a risk, and for a seller also it is a risk. Paying for an item which we don't know who is the person receiving, whether we'll receive a damaged or incorrect item, that will be the buyer risk. In case of the seller risk, whether the after shipping the item, whether I'll receive the payment or not. So that is this what seller risk. So this is the problem that whenever when we are purchasing the goods from unknown persons like this, right? So a legal concept describing the financial agreement whereby an asset or money is held by a third party. In these cases, we'll take a help of the third party, which we are calling here it as a escrow in order to complete this transaction. Now, both the parties will rely on escrow. So in this smart contract, for example, we'll see an example here. A buyer and seller agree that in order to purchase a product, buyer and seller agree you need to pay these many Ethereum coins. Okay, then buyer has sent one Ethereum coin to the smart contract address. He didn't send to the seller directly. He sent one Ethereum to the smart contract. Then buyer receives the item. After buyer receives the item, then he can confirms whether that item that he has received is correct or not, everything. Then he can click on some accept button or something in the UI. Then what will happen? Then the smart contract will send that fund to the seller. If the buyer says that, okay, I have received the damaged item, then he will raise the dispute action. Then that amount will not goes to the seller. It will be sent back to the buyer. So escrow will help like this, which act as a trusted third party solution. By using the smart contract, what are all things happened? You can see right here. You can see the majorly how smart contract worked here. So here condition met upon receiving the confirmation signal, then only contract automatically releases that one Ethereum coins from escrow to the seller's wallet. So this is if then condition, right? These are nothing but the smart contracts. If that receiving the item is correct, everything is good, then the condition is met, then that money has been sent to the seller's wallet. Okay. So what is the advantages that we'll get here? Trustless exchange, automatic execution, reduced fees, security. These are some high level advantages that we can get with the smart contracts. Now let's see what is smart contract forensics. I think yesterday you had a detailed session from Iswar Sai Prasad Garu based on the forensics, I think, right? So I think you got a clear detailed information about cloud network forensics, cloud forensics, and all various things. Now we are seeing today smart contract forensics. For this, we are taking one case study. I think it's looking like a movie, right? You can see the various characters and what is happening. What is the problem statement behind this case statement and how this problem got solved by using the smart contracts. All that we are going to see now. Hope you are all excited. Let's start. So what you can imagine the story based on seeing this. So a citizen has reported a case, some theft case to an investigator who has performing some investigation using the blockchain technology and the smart contracts and how this case has been solved and closed, right? So a simple like. So a citizen named Alex has fallen victim to cryptocurrency investment scam. He has transferred the funds to what appeared to be a legitimate decentralized finance platform that promised high returns. After investing 5 Ethereum, so the website vanished. Nowadays, we are seeing these kind of things very frequently, right? I mean, more often we are seeing here. So there are, instead of trusting or relying the government organizations, we are seeing if some person or some organization or some company is saying like, okay, invest here, we will give some 15%, 20%, 50% of the higher returns. Then we simply go there and then finally we are turning into some victims kind of, right? So similarly, same thing happened in the case of the cryptocurrency also. There is one person who is Alex, who has seen one company called Decentralized Finance. He thought it is some legitimate company, and when it has promised that I'll give higher returns, then he has invested some 5 Ethereums in that. After investing 5 Ethereum, what happened? That company itself gone. So his funds are gone, company is not able to see, and everything has been gone, right? Then he has registered a complaint with a blockchain based smart forensic investigation portal. So he has got some portal, then he has reported. So who are all the participants involved here? A citizen who is Alex here. And then once he reports the scam, then there will be an investigator from the cybercrime who receives that case and then solves it, right? And then evidence repository, he need to provide some evidences also, right? What kind of evidences he need to provide? Some website logs and what is his wallet transactions and all screenshots he need to provide. And then the investigator uses some various blockchain tools and technologies to perform the analysis, and then finally find where the issue happened, and tries to recover the money and all, automates the close. Okay, so what helps smart contracts help here? It will help to automating the case registration, evidence tracking, access control, everything is getting automated by using the smart contract. And this public or private blockchain maintaining immutable audit trail if you use these concepts. Step by step also I think we have very less time, but high level you can see what are the steps happened here. So first case was registered by the citizen. So whenever he registered the case, these are the various things that he has provided: scam URL, Ethereum transaction ID, how much amount has been lost, when this is happened, and screenshot evidence. So when this is given, automatically in backend, what smart contract will do? It will generate a unique ID. It will automatically create a case for this, and it will assign a case ID, and it will create a hash for all the information that he has provided, and it will store the transaction hash of this case registration, and then it will define the roles: citizen, investigator, and analyst. Step 2, what happened? Then that investigator assigned this evidence. Means an investigator will be, a case has been already filed, then it will automatically, an investigator will be assigned to that case, right? So the for that investigator, there will be a function, means whatever the evidences that he has submitted, that all the evidences will get hashed, and when this case has been filed, the timestamp, and who is uploading this case details, that uploader role, all this information will be automatically get created using the smart contract. Then blockchain forensics. Then the investigator used some tools, blockchain tools, in order to identify, trace what happened from when he transferred the fund to which all accounts it has, with wallets it has been transferred. Those are all trusted or not. What are the linked wallets? When at the time of the movement, known addresses are not. All this has been analyzed by the investigator. Then that exact wallet to which it has been transferred will be identified, and then everything, all these things are means recorded in the case of the smart contracts, and then these are kept as the immutable records in that blockchain. Then finally the case gets closed. That's how these smart contracts will get used in the real time. You can see here registering the case, adding the evidences, assign the investigator, adding the analysis. If you want to build on your own some case study, or if you wanted to build some sample or proof of concept like things, or if you wanted to build some use case using the smart contracts, in general, you can consider these are the things that you need to perform for this particular kind of the use cases: registering the case, adding the evidences, assigning the investigator, adding the analysis report, updating the case studies, and granting access and all. So overall, if you see, these are the things that we have discussed, right? Start from the case initiation, evidence collection, citizen registered the new scam case, then the wallet addresses. These are the some various kind of the evidences that he has submitted. Then investigator used some blockchain tracing, and he has found that root cause, and then wallet identifies which wallet that has been happened, and a complete audit trail has been created, and finally it has been recovered and the case has been closed, right? So like this thing, various phases it will involve in the smart contract forensics. This is again the same thing which is given in a different format of at each stage what is the benefit that we have got by using the smart contracts. So with that, we have completed the two concepts of the first session of today, which is what is blockchain and traceability in blockchain, and then smart contracts, and then smart contract forensics. Now let's see the last item of this first section, which is decentralized identity. What is decentralized identity, and what are the challenges that are associated with the decentralized identity, right? So let's see. Traditional identity. So whenever you go outside, if someone asks to prove your identity, what is the things generally will you? Physical credentials. I'm not talking about the digital credentials now. First, let's see the traditional identity management, right? So if someone asks to prove your identity, what are the physical credentials we'll use? Either we'll use a driver license or a passport or some other identity document we will use, right? Fine. What if in case of the digital, and nowadays something called digital identity came now, right? So you can, if you wanted to sign up, for example, you are signing up to a banking application, then you wanted to do something called KYC, right? So how you will create your own credentials? You can, you will sign up a form. You provide some certain details like username, password, and your date of birth, email, and all some various details you will provide by filling up the form. Then your digital certificates or the digital credentials get created from either government institution or from a qualified trusted service provider. Then you will be able to use that on digital identities. So what if you wanted to do for, sorry, for example, you will current in a day-to-day for various purposes, you will not be using for one single application, right? I think if you open your mobile app, I think you can see almost some 20-30 different apps. So if you wanted to create these credentials for each and every application, it will be a tedious task, right? Providing digital identity for if you are interacting, say, with some 10 different applications, creating the 10 different credentials will be a tedious task. That is how currently means in the previous traditional technologies it is happening. So whenever you consider in this traditional identity management system, what are the key components? Identity repository. Identity repositories means some centralized database. Whenever you submit that form, right, you are creating a digitalized means digital identity. You are signing up and you are providing some details, right? So all these details will get stored into one identity repository, which is nothing but a centralized database, right? After that, there will be some authentication mechanisms, which there will be traditionally what type of the authentication mechanisms we have. We have either username and password based authentication, or we have a magic link authentication. What is magic link authentication, right? So sometimes we'll not use username and password. Instead, we will just give our email ID or something, and they'll send a link to our email, and then they'll say, using that link, we'll be logging to that particular system. These are the other kinds of the authentication mechanisms. Then authentication and access control. There is a different part, right? Not authorization. So in traditional system, we also have authorization, means that system will decide who is authorized to access this application and what type of access he has, which is nothing but a access control. Then the identity lifecycle management. Identity lifecycle management tells what if a new user gets the new account creation, and then updating of the existing details, or if some user get deactivated, then removing of that user accounts. So these are the basic components in the traditional identity management system. We have identity repositories, authentication mechanisms, and authorization and access control, and identity lifecycle management. When a new user comes and or an existing user become inactive, or what type of activities that we will perform as part of the traditional identity management system. So there are some pros and cons also associated with this traditional identity management. It is familiar, username and password, and the sending a link to the email. These are most familiar and easy to implement, and these got widespread acceptance, worldwide recognition, right? These are easy techniques. As of now, traditionally from long time, many people are using these techniques for the identity management. But what are the problems associated here, right? Security vulnerabilities, privacy concerns, and the user experience. Security vulnerability means we don't know. We are putting some simple passwords nowadays, like okay, test it 1, 2, 3. For giving password also, we are keeping password as password, which is surprising. So those kind of the passwords we are using. So which are, if the hacker uses some brute force approaches and all, they can easily hack the system by compromising the password, and privacy concerns, and then user experiences. These are some cons. In order to mitigate this, what is came up as called as the decentralized identity management. So what is decentralized identity management here is, yes, from a trusted means from a government entity or from a trusted qualified trusted service provider, you will sign up to an online service. You will provide all this device, means all these details, and you will generate some digital credentials, and these digital credentials you will store in your mobile wallet, and whenever you wanted to prove your identity, you will authenticate using this mobile wallet. So this is what called as the decentralized identity mechanism. So in this decentralized identity mechanism, you are not signing up for multiple times for the multiple apps and all. So this is the digital credentials. It is not getting created in the third party platform. Instead, these digital credentials are getting created on your own device, and those are getting stored in your own mobile wallet, right? So this is what called as a decentralized identity management. So you don't need to, for example, now you are interacting with some 50 different apps, and if you wanted to prove your identity, you don't need to do a KYC, or you don't need to submit some, again, create your digital credentials 50 times, right? So you, wherever it is required, you need to prove your identity. You use your credentials, which is present in your mobile, to authenticate yourself. So what is the purpose here? Means privacy, authenticity, and portability here. Privacy. So now these details are stored in your own mobile device, and authenticity, you are only managing. You will decide to whom you wanted to share and whom you don't want to share. So you can also limit how much amount of the information you need to provide also. You don't need to provide the complete document. For example, you are registering in a particular app, there you just need to provide your date of birth. You don't need to provide your email addresses or your passport numbers and all. But if it is there, everything it is part of some document, then if you share the document, all the details will be shared to them. But here in the case of the decentralized identity, you can also decide with whom you can share this identity information and how much amount of the information also you can share. You can decide by yourself. And portability, as you know, you can carry this anywhere across different apps, easily carry, and you can authenticate yourself, kind of, right? So what is the technology behind this decentralized identity here? You have verifiable credentials, ID wallets, and decentralized identifiers. Verifiable credentials are nothing but, what is it? What it is? It is nothing but your digital credentials which you got created. So it is nothing but secure documents or some credentials which you have created, and those credentials you are saving into your mobile wallet, and that will be assigned with some unique decentralized identifiers, which are, we are calling it as here, DIDs. So advantages just now we have seen. Verifiable credentials in the decentralized means whether it can be licenses or any other legal documents, everything you can store that as a verifiable credentials, and then on your mobile you can save these as in your identity wallets, and then you can use these wherever you go to authenticate yourself for these digital credentials, right? So these are the, if you see the advantages and disadvantages with decentralized identity, security is automatically increased because you are only deciding, and then user experience also increased. Why user experience is increased? Any idea? For example, if you wanted to authenticate, if it is a bank or something, or some of your organization app or something, everybody will provide a lot of restrictions. Okay, if your password shouldn't get hacked, then you need to choose some complex password, and you need to change every three months or every 6 months. So these and all some restrictions are there, right? But with the help of these digital credentials, what happened? Already the credentials are getting stored in your mobile, and you are just giving your consent to the particular app or application where your identity is required to prove. So user experience is much increased, and then frauds are getting reduced, and it can be used across various different organizations or different countries. When it is get adopted, automatically the costs are getting reduced. But the problems, what are the problems associated with the decentralized identities? Adoption challenges, regulatory challenges, and lack of short-term interoperability. Adoption challenges. What is the problem? Because an educated technology knows person can easily, quickly adopt this change. But what about, think about how many people in the country are literate and how many knows the technology. So it will take some time for everyone. If there is some new kind of these digital identities comes to adopt to this technology, it will take time. Similarly, when these are just came into the picture into the organizations, or means um, in the digital world, and it will take time to be compliant with all the regulations and to be compliant with all the governance and all. So those are some high level challenges that you can say which are associated with the decentralized identities, right? So if you, let's see clearly the major differences between a traditional and a decentralized identity. If you see, right, in case of the traditional identity, these credentials are being provided by a digital identity provider. But whereas in the case of the decentralized entity, yes, initially it will be provided by the, it will provided and maintained by the trusted, qualified, trusted service provider, but it will be maintained by you only, right? So it will be users. Whereas in the data storage, just now we discussed, in case of the traditional databases, all your personal details, usernames, password, email, phone number, everything will get stored whenever you sign up. It will be stored in the organization centralized database. If it is get hacked, all data gets hacked. But whereas in the case of the decentralized identity, where this information getting stored, this data is getting stored as a digital credentials on your mobile device. Or if you want to opt, you can store the digital credentials in a cloud storage also, which is completely secured. Right? Similarly, the data control. So organizations hold and manage this data whenever they want. But here you can decide what kind of data that you wanted to share with whom. And the data disclosure, organization often demand information than required, but user can disclose only the information which he wanted to give. Portability, just now we have seen these credentials can be directly stored in your mobile wallet, and then you can carry them anywhere. Like that's how the portability of the application has also been increased. Security. See, security focuses on the safeguarding of the centralized database. As we see in centralized database, it is always vulnerable to the single point of failure. But whereas in the case of these decentralized identities, all the details which are getting created as a digital documents here, those are saved here in your mobile wallet itself, right? And all these are getting encrypted using the encryption techniques, strong encryption, cryptographic encryption techniques, right? There is no way that it can get compromised. And finally, these are some industry use cases where you can use. I think running out of time. I'll give a break. So yeah, limitations. This is what we discussed. Limitations with the decentralized identity, interoperability, technology literacy, and scalability. It will take some time for the people to get adapted to this technology and to be used by the many of the people and to be compliant with the various regulations and to be compliant with the government policies and all, right? So that's why even though it is providing some efficient and secure way of transactions and authentication and identity operations, it still has its own limited challenges. I think that's all. With this information, I'll just pause here. So I'll request for any queries.
That's an excellent session, sir. That's an excellent session. It's really surprising how quickly the 90 minutes has gone.
Great to hear.
Now let's take a break for 10 minutes, sir. Let's
Yeah,
take
yeah,
a
sure.
break for 10 minutes and the participants will rejoin within 10 minutes, sir. Thank you,
Sure.
sir. All the
Thank you.
participants are requested to join within 10 minutes, sir. Thank you.